We present TiNO-Edit, Timestep and noise optimization for robust diffusion-based image editing. Although text-to-image diffusion models like Stable Diffusion can generate images easily from noise with text, they have limited editing controllability. Prior work like TiNO-Edit proposed to sample a Gaussian noise N from its latent space and define a starting time step T to noisify the input image via the forward diffusion. Then, SDUNet will iteratively predict noise and extract it from the input via the reverse diffusion. When T is too small, the output doesn't reflect the desired edit. But if T is too big, the output diverges too much from the original image. Furthermore, the result can also vary greatly with different N. The question becomes how to find the optimal NNT automatically. To break down the previous process more in depth, an image I is encoded to a latent image L using a VAE encoder before it is noisified via forward diffusion. SDUNet takes the noisy image and target prompt P to denoise the image across K time steps, where the final output image is decoded using the VAE decoder. TiNO-Edit automates this process by optimizing relevant inputs and parameters while freezing the models. We have designed a set of optimization objectives that depends on user inputs like the original image prompt PO and the optional additional input set A, and use a target prompt semantic loss to enforce semantic alignment between the target prompt and output image via their clip text and image feature to maintain low-level visual consistency between the original image and the output. We also minimize the difference between the VGG features of these images. In the case of reference-guided image editing, we want to minimize the cosine distance between the clip image features of the reference image IR and the output. But one major problem with these objectives is that the optimization happens in the pixel space, which is very expensive with higher resolution images. So we propose to perform optimization in the latent space, which is not only more compact, but also avoid a layer of indirection caused by VAE. The problem with this approach is that the clip and the VGG models operate in the pixel space. To train the latent space equivalence of the clip vision model, which we call latent clip viz, we compute the cosine distance between the outputs of these models to update latent clip viz. The same applies to the latent space equivalence of the VGG model, latent VGG. After training, we can replace clip and VGG to optimize the output in the latent space. The weighted sum of individual objectives is our total loss function. To put everything together, TiNO-Edit takes an input image I, its text description PO, our target prompt P, and additional optional inputs A, which can include the reference image and more. It initializes the starting time step T and the number of time steps K, where the time step values are uniformly distributed. The noise is sampled from a standard normal distribution, and the original image is encoded to the latent space. We compute the editing area via our masking mechanism. The algorithm takes W optimization step, where each step starts with image noisification via forward diffusion, except that the areas outside the editing mask are kept the same. Each optimization step consists of a complete denoising process from noisy image to pristine output. Again, we use the editing mask to maintain consistency. After a complete denoising process, the noise N and all time steps TKs are optimized with respect to our loss function. Finally, at the end of the optimization process, we decode the latent output image back to the pixel space. TiNO-Edit supports various editing capabilities, including pure text-guided image editing, where it can better capture finer details compared to the baselines. It can also take reference images and capture the characteristics of the corresponding objects more faithfully. The method may take user input strokes and turn it into objects that look cohesive with the rest of the images. The same idea may be applied to image composition, where a set of roughly composed image layers can be refined to improve harmonization. Last but not least, TiNO-Edit can incorporate custom concepts from Dream Boost and textual inversion to edit images accordingly. For more information, please visit our project page. Thank you.